Ever wonder how people invented binary code? What about hexadecimal, or octal, or any of those other weird-sounding words that are so important to computing and programming languages today? Don't be intimidated. A lot of it can be understood, which is a simple concept. Cycling. No, not that kind of cycling. Mathematicians call it a modulo operation, but the essence of it is you are using cycles and patterns to change a large number into a smaller one. Let's see how it works. First, a quick definition. When you mod a number, say 202, by another number, say 7, you are dividing 202 by 7 and looking for the remainder left over. In this case, the remainder is 6, so 202 cycles down to 6 when divided by 7. In fancy math terms, this would mean that 202 mod 7 equals 6. Easy enough, right? But what if we were asked 3 to the power of 48 mod 7? That is, what is the remainder when 3 to the power of 48 is divided by 7? You can't just type this into a calculator and expect an answer, but there's an easy way to solve this. First, we want to separate 3 to the power of 48 into a multiple of 7 plus the remainder. Remember your exponent rules? We all know that 3 to the power of 48 equals 3 squared to the power of 24, or 9 to the power of 24. We can now rewrite this as 7 plus 2 to the power of 24. Now, if you have any familiarity with binomials, you know the pattern. Take the simple a plus b squared. We know this is a squared plus 2ab plus b squared, but you can also write it like this by factoring out the a. Therefore, a plus b squared is just a multiple of a plus b squared. This is true no matter what the power is, because a will be distributed to all terms except the last one, which will always be a power of b. You might be wondering what this has to do with the previous problem. Don't worry, it's all coming together. All this means is that if we expanded 7 plus 2 to the power of 24, all terms would be a multiple of 7 except the last one, as shown here. Because we only care about the remainder and don't want any multiple of 7 in our answer, we will disregard every product with a 7 and focus on 2 to the power of 24. It's still too big. Let's repeat the process. We find 2 to the power of 24 equals 2 cubed to the power of 8 equals a to the power of 8. Likewise, this can be written as 7 plus 1 to the power of 8, which we can shortcut to a multiple of 7 plus 1 to the power of 8. Again, throwing away the multiple of 7, we find the remainder to be 1 to the power of 8. Therefore, 3 to the power of 48 cycles down to 1. Thank you for watching, and I hope this video helps you understand modulo operations.